Okay, PF is factoring polynomials, and we're doing day 2. So here we're going to talk about how to factor a difference of squares and to factor the sum or difference of two cubes. So again, we see our steps for factoring. And so the first thing we're always going to do, remember, is to check to see if it has a greatest common factor. The second thing to do is count the number of terms and then factor it. So today we're going to do if there's two terms. If it's a binomial, we're going to see if there's a difference of squares or if it's a sum or difference of cubes. Then 3 terms, and then we talked about 4 terms in the previous lesson, which is grouping. And then we always check to make sure that it is factored completely. So the difference of two squares, it says if a and b are real numbers, variables, or algebraic expressions, then a squared minus b squared is equal to a plus b times a minus b. So this right here is going to be given. This is going to be your problem, okay? And over here is going to be your answer. This is the solution that you're going to give me. So how do you find a? Well, remember, a is going to be the square root of a squared, and b will be the square root of the b squared. All right, so let's look at example 1. It says to factor. So our first step in factoring, remember, is to look for the greatest common factor. So look at A. Do either of these have a factor in common other than 1? They do not. Step 2, count the number of terms. There's 2 terms. So then if there's 2 terms, you ask yourself, is it a sum, which means a plus sign between them, or a difference, which is a minus sign? So we look at this and we see it's a minus sign, so we know it's a difference. And the only difference we know right now is squares. So is this a difference of squares? Well, let's see. If this is a difference of squares, then both of the terms given here will have square roots. So let's check the first term. What's the square root of x squared? X. What about the square root of 49? 7. Since they both have square roots, then yes, this is a difference of squares. So x is my a, 7 is my b, and we're going to go plug it into that formula. So a plus b times a minus b. And then check to make sure this is factored completely. Neither one have a greatest common factor other than 1. Neither one are going to, they're both 2 terms, but neither one are a difference of squares. Therefore, this is factored completely. So look at B. Remember, go through your steps of factoring. Is there a greatest common factor? Is 36 and 25 both divisible by something other than 1? They are not. And then we have an x squared here, but we don't have an x in the other term. So no greatest common factor. 2. Count the number of terms. There's 2. So ask yourself, is it a sum or a difference? It's a difference, and the only difference we know is squares. So do both of these terms have square roots? Well, let's find out. What's the square root of 36x squared? We'll take it a piece at a time. What's the square root of 36? 6. The square root of x squared? X. And then what's the square root of 25? 5. Since they all have nice, pretty square roots, then this is a difference of squares. So we have our A right here, and this is our B. So let's plug it into our formula. A plus B times A minus B. Check to make sure both parentheses are factored completely. Neither one of them have a greatest common factor other than 1, and they're both 2 terms, but neither one is a difference of squares. So C. Let's check it. Do they have a greatest common factor? Is 25 and 4 both divisible by some number other than 1? They are not. First term has an x squared. Does the second term have an x? It does not. So there is no greatest common factor. So how many terms? 2. Sum or difference? It's got a minus sign, so it's a difference. Is it a difference of squares? Well, let's find out. What's the square root of 25? Of x squared? What's the square root of 4? Of the y squared? So since we have nice pretty square roots, then it is a difference of squares. So we're going to take a plus b times a minus b. And then let's do D. But you know what? I'm going to change D a little bit. So a couple of my classes we changed it, and a couple of them we didn't. So if you're watching this and you're already in my class and we didn't change it, then you just have a new one here. So we're going to make that 2 into a 4. So let's check. is there a greatest common factor? There is not. How many terms? 2. Sum or difference? Difference. So is it a difference of squares? Does 1 have a square root? Remember, you told me the square root of 4 was 2 earlier because 2 times 2 is 4. So is there any number that times itself will give me 1? Yes, 1 times 1 is 1. So the square root of 1 is 1. What about y to the 4th? Well, you can tell if it has a square root because remember we had talked about the exponent over the root thing with radicals before. So if it's square root, remember square means 2 in algebra, so we can just divide this by the 2 coming from the square root. 4 divided by 2 is 2, so we know the square root of y to the 4th is y to the 2nd. All right, so there's my a and b. So I got a plus b times a minus b. So check it, make sure it's factored completely. Neither parenthesis has any greatest common factor other than 1. The first parenthesis has a plus sign, even though it's 2 terms, so we can't do anything with it. But look at that second parenthesis. That's another difference of squares. It's got the minus sign, it's 2 terms, got a minus sign, and they both have square roots. So we're going to do a difference of squares again. This first parenthesis is part of my answer, so just bring it down. And then let's take the square root of the second. The square root of 1 is 1. The square root of y squared is y. And so we have a plus b times a minus b. Check and make sure both of those parentheses are factored completely. There's no greatest common factor in them. There's no difference of squares because they're 2 terms. So these 3 together would be our solution. Then we're going to talk about factoring the sum or difference of 2 cubes. So real quick, notice we didn't talk about a sum of squares. There is no formula for sum of squares that will work. So if they have square roots and there's a plus sign between them, they are not factorable, okay, unless they have a greatest common factor. All right, so let's move on to the sum or difference of 2 cubes. So first it talks about the factoring of the sum of 2 cubes. So just like on the other one, this is going to be the problem. This is your given. And this is what you're going to write as your solution. Notice the sum of 2 cubes has a plus sign in it. Then we're looking at the difference of 2 cubes again. This is your given. And over here is going to be your solution. This is going to be your answer. I should have wrote that on the one above. Notice in the second one here that it's a difference of cubes because it's got a minus sign in it, okay? And we know it's of cubes if the 2 terms both have cube roots. And so you're going to find a by taking the cube root of a cubed, and you're going to find b by taking the cube root of the b cubed. Now, how do you take the roots of them? Well, you could use your calculator, or remember, like a cubed would be like a times a times a, and if you're looking for the cube root, you're looking for 3 of a kind. And I'm going to do that on here, but if you know how to use your calculator, you could do that as well. All right, so in example 2, now just ignore this that up there at the top. Notice it's one of the problems in it. I redid my slide and I forgot to take it out. But let's look at A. And let's start with our rules of factoring. Does it have a greatest common factor? Well, we have x cubed and 64. Can't factor anything else out of them but a 1. So no greatest common factor. How many terms? 2. Sum or difference? It's a sum. The only sum that we can do is a sum of cubes. Do these 2 have cube roots? Well, the first one is x cubed, so yes, it does. The 64 we may have to go work on. So let's see. What is the cube root of the x cubed? Well, remember, a root and an exponent will cancel, so cube root of x cubed is x. Or we could have said that means there's 3 x's and we're looking for 3 of a kind, so we take 1 out. Now for the 64, I'm going to come over here and do my factor tree that we did a couple lessons ago. So we know that 64 is like 8 times 8, and 8 is 4 and 2, so 4 and 2. 4 is 2 and 2, bring down the other 2. 4 is 2 and 2, bring down that 2. Now since we're doing the cube root, we're looking for 3 of a kind. So I've got a group of 3 there, so I'm going to take 1 out for the group. I have another group of 3 here, so I take one of them out for a group. And remember, when we take them out, we multiply what's on the outside. There was nothing left, so we don't have anything on the inside. So the cube root of 64 is 4. So using my formula from the other page, or the other slide, it says that we're going to do our A plus B, make sure you're using the sum one, okay, times. Now when we go to do the one that says the A squared and the B squared, I'm going to use little parentheses for each of the terms that are squared. So I'm going to have an X in parentheses squared. The formula has a minus. Then it says A times B, so X times 4. The formula has a plus. And then it's B squared. So I'm going to put that in parentheses. My B is 4 squared. And I'm going to close my parenthesis for that second one. Then we just need to simplify that second parenthesis really. So I'm going to bring down the first one, the X plus 4, times, what is X squared? X squared minus, what's another way we can write X times 4? 4X plus, and then what is 4 squared? 16. Make sure they don't have any greatest common factor. Make sure the two terms is not a sum or difference of cubes or a difference of squares. We can't do anything else, so there is our solution. So look at B. Do they have a greatest common factor? Don't think so. How many terms? 2. Sum or difference? Difference. Squares or cubes, because with a difference we have two different options. It can be a difference of squares or a difference of cubes. The easiest way is to look at your exponent. Squares is 2, cubes is 3. Which number is that exponent divisible by? It's divisible by 3, so this could be a difference of cubes. All right, so we're going to take the cube root of both of these. So I'm going to come over here and work out that cube root of 125. What multiplies to give me 125? Well, it ends in a 5, so I know it's divisible by 5. So it's 5 times 25. 5's prime, and 25 is 5 times 5. We're looking for 3 of a kind, so we're going to take out a 5. What's the cube root of x cubed? X. What about 8? Well, let's see. 8 is 4 times 2. 4 is 2 times 2 times 2. 3 of a kind, so we're going to take out a 2. So the cube root of 8 is 2. So there's my A and my B. So I'm going to set it up. It's A, make sure you're using the difference formula, minus the B, times, and then here's a squared one, so I'm going to put it in a little parenthesis. So my A, close it, squared. The formula has a plus. A times B, formula has a plus, and then it's B squared. So I'm going to put that B in parentheses, square it, and close the second parenthesis. And then we're just going to simplify the second parenthesis, so bring down the first one. Then we have 5x squared. Remember, 5x squared means 5x times 5x. 5 times 5 is 25. X times x is x squared. That's why we put it in parentheses, guys. If you don't, you're going to see it as 5 and then x squared, okay? It's not just the x that gets a square. The entire a term does, which is a 5x. All right, bring down your plus. 5x times 2 is 10x. Bring down your plus. And 2 squared is 4. And close your parenthesis. Make sure there's no greatest common factors. Make sure you can't factor out anything. And so there is our solution. On C, we're going to do the same thing. So on C, we're going to take it's 27m cubed minus 1000n cubed. So, does it have a greatest common factor? You don't think so. Count the number of terms. There's 2. Sum or difference? Difference. Squares or cubes? The exponent here is divisible by 3, so probably cubes. Now, so we're going to go find the cube root of 27. That's 3. The cube root of m cubed is m. The cube root of 1000 is 10. And the cube root of n cubed is n. So there's my A and my B. And just make sure you plug it into the appropriate formula. So we have A minus B times A squared. So put it in parentheses. Squared. Formula has a plus. A times B. Formula has a plus. And then b squared. So put that b in parentheses, squared, and close it. Work out your second parenthesis, simplify it. So I'm going to bring down the first. 3m squared, that's 3m times 3m, which is 9m squared, plus 3m times 10n, multiply your numbers, 3 times 10 is 30, and you can't do anything with m and n, so just bring it down, plus 10n squared, 10n times 10n is 100n squared. Make sure there's no greatest common factor. We can't do anything with the 2 terms because we haven't learned 3 terms yet. And so there's our solution. And then D. Again, steps are factoring. First step, does it have a greatest common factor? It does not. Count the number of terms. There's 2. So sum or difference. Difference. Squares or cubes, that's divisible by 3, so cubes. So let's see, what's the cube root of 1? 1. And the cube root of y cubed is y. So I got my a and my b. Plug it into the appropriate formula. This is a minus b times my a squared plus a times b plus my b squared. And then just simplify that second parenthesis. So bring down the first one. 1 squared is 1. 1 times y is y. And y squared is just y squared. No greatest common factors. I can't factor out that 2 terms, so there is our solution.